Hey there, let's do another Leetcode question. I'm going to be acting as a tech interview candidate, and I'm going to be recording myself talking out loud as if this is a mock interview. And worst of all, I'll be using this Google Doc over here instead of a normal IDE because I like pain. So let's choose one at random, and I'll start the timer. All right. We've got 1897, redistribute characters to make all strings equal. You're given an array of strings of words, zero indexed, and in one operation, pick two indices within them where the first word is a non-empty string and move any character from the first word to any position in the second word, and return true if you can make every string in words equal using any number of operations and false otherwise. So is this an anagram question? No. So I don't understand this just yet. Return true if you can make every string in words equal using any number of operations and false otherwise. Interesting. So we can move characters around between words within the list. Like we can move the A in the first one, in the second one to the last one, and that makes all of them A, B, C. So it is kind of anagram because we don't care about the order. And the second one is A, B, and A. One thing I was kind of trying to think about was what happens if you have a misorder within the word, but I guess you could just move it to the first one, then move it back and put it into a new place. So reordering a word itself is considered acceptable because you can do any number of operations. And we're only returning true or false. We don't actually need to know what they are. So this does become essentially an anagram type question. And what I mean by that is we don't care about the word. We just care about the character counts in each of the words. And we want to make sure that as a whole, the number of character counts for all words is equal. Yeah, I think that's right. So I'm just talking out loud. Don't anagram-ish. We want counts of all characters to be equal throughout words. We don't actually care about the distribution, etc. Just true if possible or not. So is it ever going to be the case? So here's what I'm already starting to think. I'm talking out loud with the interviewer in this example. Are we always going to have are we going to have a valid input every time? Let's assume yes. And in fact, they give us some constraints here. Word length between 1 to 100 fits in memory. And each string is up to 100 characters. They're all lowercase English. Can we ever have a case where all the characters counts are equal and we are still false? Is that ever possible? This ever fail is basically what I'm trying to say. I'm trying to think of a case where character counts are equal, but it's false. So this will eventually be resolvable because it'll become AB, AB, and that is valid. And it doesn't matter what order any of these things are. So I think that is the case. And the nice thing there is counting all the characters is just going to be O of, let's just say n times m, where n is length of words, m is count of characters in a word on average, or max in this case. And space is equal, what's the space complexity going to be? Technically just m for the number of unique, or number of characters. Number of unique characters, actually. Because what I need to do is just check for the counts. I'm not putting in spaces and stuff like that. So this would be a valid one. If we were given something like A and B, C, what did they give? A, B, and A. let's just do it with their actual ones just to confirm. So false because counts is A is 2, B is 1, and there's nothing you can do to fix that because you can't create new characters. Whereas this one, let's just make sure this works. A is 3, B is 3, and C is 3. So yeah, all right. I think that makes sense. I'm feeling confident enough in this that I think it's probably worth implementing at this point. There are other approaches where well, I'm even trying to think of brute force approaches, but for now, I just want to start with a dict of char counts. I'll point out to the interviewer that there is an import, like the import counter from default collections, I think, import counter, and then you could do counter over all of the words. And let's not do that in this case. I was actually trying to think about how we do it. We'd have to like merge all the words together. So one way you could do that is like saying words.join, or that would be O of n operation, and then you do a counter over them, and then the values, I think something along those lines, and then make sure that they're all equal. The set of values is length of the set of the values is equal to 1. Something along these lines is maybe a one-liner type approach to this, and at the end of this all it would become joining the words is O of n, counter over all those words is O of n times m, and getting the set of that is going to be O of n, m in this case, and then getting the length is 1, so O of nm through it all, and O of m space. But pretty good chance we're not allowed to do that, so let's move on from there. So let's create our function skeleton, and we're about 7 minutes in. And what we'd like to do is we're passing in all anagrams, eventually anagram. I need a better name. And our input's going to be words, which is a list of strings, and our output's going to be a Boolean. And what I'd like to do is create a counts dict, and we could even use another thing we could use is a default dict with int, because that initializes to 0. But let's say we're not allowed to do that either. So for word in words, for char in word, counts of char is equal to, let's see if we can at least do this as a semi-inline. If char in counts, else 1. And what I'm doing here is just incrementing the counts inside of for that key value if it exists, otherwise initializing it to 1. And let's just bring this down one step. And finally, reiterate over, make sure they're all the same. Valid char count equals for value in counts.values. Oh, right. Let's just do it as the way we had talked about earlier. return that the length of the set is equal to 1. This will still be a O of turning the values, which in the worst case, in the absolute worst case, we have like some sort of words is equal to A, B, C, D, and so on. So there's all unique characters, and actually it'd be 26. So you know what? This actually does break down. M, which for lowercase alphabet, 26 is constant. So O1 is constant space. So actually we don't ever have to worry about this being any larger than constant space because of the number of characters allowed, unique characters allowed. Yeah, because counts here is just for a char. So O of 1 space since 26 alphabet. Otherwise we'd say M, O of M. Okay. Let's have a look at that. We're about 10 minutes in. We could do this over iteration where we just get the first value and iterate through it and make sure that they're all the same and break out false otherwise. But I think this should give us an initial go. I'd like to have a go and see if this works now. So they call it words, list the string the same. That's good. Before I run this, I just want to confirm the final one. So this is O of M, and this is O of M. So we're still doing an O of NM time complexity here. This becomes O of 1 time and space. Max unique chars equals 26. Okay, will this run? Another thing we do if we didn't like this double for loop is we could merge all the words into one giant word, but that seems unneeded. We need to make sure that we return if the length is equal to 1. Is there ever a case where we have a false? So a question here is, what is the right answer for an empty list? Should an empty list return true or false? And that's a question for the interviewer, because right now I believe it will return true because the length will, oh no, it'll return right now false because the length won't be equal to 1, it'll be equal to 0 because we haven't added anything to counts. Okay. Well, let's have a look and see how it goes. Make sure I have no tabs. All right, what do we get? Did it work? Did it not? Oh, sorry. 1 second. All right, it passed the test cases. Let's submit it. Oh, wrong answer for A and B. It returned true. Why is that? So we created a count of A is 1, B is 1. They're not the same character. Count are keys, not values. Interesting. Wait. No. They don't need to be equal to 1. They need to be equal to the length of the number of words. That's where I think my mistake was. So the reason this one worked here is because that was a false case. And this one was true because there was 3 letters and 3 words. So it happened to be the case that all the values were the same and they happened to be 3. So we both want to check we're checking all the values are the same number of chars, but also checking count of that count is equal to the length of number of words, because we need 1 for each. So technically this a case I would have passed and did pass in there, but let's create another example right here, and I want to make sure I'm thinking about it correctly, is AA, BB, and CC. So that's where we would have actually fallen apart, and I should have checked that earlier, but it's okay. We're finding it now. The interviewer would probably start hinting at this. So what happens here is counts of A is equal to 2, B is equal to 2, and C is equal to 2. And this looks correct, but it's not actually correct because we aren't able to make them all the same. So we also need to check, a check that counts the value 2 is equal to length of words 3, so false here. So let's actually create this set. Let's make sure the length of that is equal to 1 and the first value of that is equal to the length of words. Okay. And let's pull this over here so we can actually see it a little bit. Okay, let's not click the format button because we don't have access to that. We're trying to make sure that it's 1 as is before, the length of it, the number of characters are all the same, and that the number of characters is equal to the length of the words input. So again, this will still be the same O of 1 essentially at the end of this, because the unique char counts will always be for the number of unique characters, which is 26 in this case max. And getting the length as well as checking if it's equal is all 1. So let's do a check with the test case. Oh, tabs and spaces get weird. This is unrelated. Return outside function. Oh, is my spacing off? Sorry, guys. Okay. Let's try this again. Getting the unique char counts. You can't just get the first value from a set. That makes sense, but we'll just have to turn it into a list, or there are some other approaches, but so let me just put that here so you guys can see it. I'd say the other option is we'd say count the values, which is the list, and we'll take the first one of that, since we know they're all unique at that point. Okay. Dict values object is not subscriptable. It's an iterator. We'll have to do the same thing there. So you can turn that iterator back into a list by putting list around it, but it's a little annoying to do. Let's just take the unique, a list of that in the first value first. Actually, so I'm just turning it into a list, so the iterator slash set in this case, and then using the first one there. And that passes for that one. Let's have a look here. And doing this is still going to be O of 1 in time. Oh, all right, we have another edge case which I hadn't considered, which is what if this is true if they're all in the same word. So I'm surprised that this returned true, because we have 2 for ABBA. Let's copy that over and double check. And so A and B are so why on earth does this work? No, my output was false, but it should have been true. Oh, it's the edge case of where there's a single word. We don't need to worry about whether or not they're equal. Single word will always be true. All right, good to know. If the length of words is less than or equal to 1, return true. And this kind of goes back to the question of what do we do with an empty list? Do we want it to return true or false? What did they tell us? They say that it'll always be at least 1, so we don't actually have to worry about it. So for now, we're going to turn it into a true. And that's tabs. Now it's spaces, and let's do a run check. And a submit. Oh man, not a good showing, guys. Sorry about that. So why is this false? Why do I think this is false, yet it's true? I'm going to assume that all the character counts are the same. And yet somehow it made it had an issue. And the problem was you can add and remove words. Can you? Can you take away characters? And so that's kind of a question I have. You can pick 2 distinct indices where one is a non-empty string and move any character from words of I to any position in words of J. I don't get it. What's wrong with this one then? Well, let's see. We've got we're about 24 minutes in, so we do have time to think about this. Why is this supposed to be true and yet mine thinks it's false? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 words and only 3 characters. So the mistake I'm making here is thinking that the length of each character needs to equal the length of words. Because here, I think you could just make every single one of them ABC, I'm guessing. So it's not the case that, or AABBCC or something like that, where you don't actually have to make them equal to the words, but they need to be a multiple, at least the length of the words and or a multiple of them. Is that correct? Because what I've been doing is making sure that or some multiple. Is it just greater than the length of words here? I'm just reordering this to make it a little easier to understand. So I think the problem lies in not the unique character counts. That has to be the same. So that's still true. But the actual character count doesn't need to equal the number of words, because here there's only 3 characters, but you can still create like ABC, ABC, or whatever for each of them, and it matches up. So it needs to be a multiple of words. Is that how it works? Like modulo? Like the character count modulo length of the words is equal to 0. Would that work or would that break? So let's say AAB is a valid one where counts as A is 4, B is 2. Huh. So maybe my original assumption was wrong. Though technically in this one, is it the case that they all need to be the same, or is it that they need to all be multiples of the length of the word? Something like that. That might be the case instead. And it has to be at least 1. Let's just confirm that. So this is considered a valid string. And now our counts is 6 and 3. And length of words is 2. Length of words is 3 now. 6 modulo 3 and 3 modulo 3. Okay. So instead of doing a set, what we need to do is for every count, confirm it's greater than or equal to the length of words and modulo and divisible. So for count in count.values, if count is less than length of words, or count modulo length of words not equal to 0, return false. Otherwise we return true. So I think that allows us to get to where we're trying to go. If either it's not enough letters, not enough characters, or the character count is not a multiple of the length of words, then we have to break out. So let's try that. And this is just a O of M operation. And technically, we don't need to, well, no, we do need to do it for each character. We don't have to set it. Yeah, okay. Let's try it. So you guys can see what's going on here. We have this. And if the count is, for each count, if it's less than the length of the words, or not modulo 0, not divisible by it, then we return false. Otherwise, there are enough characters that we can turn this into a valid string. So let's try it. Okay, runs in the test cases. Let's see how it does on the actual one. All right, there we go. Well, that was a bit of a journey. We're at 32 minutes roughly. But it is kind of interesting. It's good to see that we have all these edge cases that my original assumption right here was actually not correct. And I think I needed to double check that way ahead of time. It would have saved us quite a bit of time, probably 10, 15 minutes. I think the general concept was straightforward, getting the count of characters and then doing something with it. That's where things started to get a little bit finicky. So the problem was not that we had the wrong inputs, it's that we needed to figure out how to validate and check the claim that this was a all strings could be equal if you redistribute the characters. And so it wasn't just that they had to be equal to the length of words. That was true for some of the test cases. And it wasn't just one, they didn't need to all be the same. In fact, they could be different. I really needed to try out some more test cases in the beginning. I think if I had tried out and created some unbalanced test cases right here, I would have immediately realized that counts could have been equal to something different, but related to the length of the word. And I think that was the key requirement that was missing right here. All right, that's pretty cool. I'm pretty happy with this question. I think I've learned something useful from this. And even though we didn't get there straight away, if you're applying for an interview and you're able to kind of talk it out with the interviewer, they'll be able to kind of call out your assumptions here. Especially for an entry-level interview, this is totally fine. You're not going to be, it would have been great if I had gotten this straight away. Don't get me wrong, I wish I had. But if you're able to kind of talk about what mistakes you made, how you resolved them, and how you tested them with these examples, I think that'll still gain you a ton of points in interview point land. And I think it's still very nice. So anyway, hope this was interesting to you guys, and see you next time.